Okay. Okay. So in the previous class, we were doing this error and measurement, which is the important topic. But in this, I already teach so many things, so I'm not going to repeat. Just go through in the previous. I left at that particular point, somewhere here, or maybe not here. Propagation of error in quotient or in product. Okay. So basically, I recall from you guys from this particular point, propagation of error in addition. Is this clear? So in the previous class, we already know what is error, and just for a glance, just a bit so I can go a little bit more behind so you guys know in a proper way. Where is that? Estimation of error, absolute mean error, and then estimation of error, and then relative, and then okay. So the questions already we done in the previous class, but wait, where is the error? Sir, Pranav is the new student. Beta, sorry. Siddesh sir, Kaniska is the new student. Pranav is old one now, right?
Sorry, sir. Typing mistake. Sorry,
It's
sir.
okay. I know who is the new. It's okay. Okay, so the basic thing, error we completed in the previous class, or you can say mathematical operations on error also. So there are three types of in general error. Okay, so this one is the first one, absolute error, and then we have. So quickly just revising you guys, absolute error, the difference between the true value, or in general error. I hope and I believe you guys know error is nothing but true value minus measured value. Okay, and why should I apply mode? I apply mode because to make it positive, nothing more than that. You can write it in a simple way also. Then your error can be positive, negative, or zero. It depends on the situation. Is this clear? Or yeah. So quickly I'm going to complete that particular portion in the next 10 to 15 minutes, whatever we were remaining in the last class. Then this class is going to be the majorly dependent on dimensions and dimension analysis and the applications. See, the topic is very small, but the importance of that particular topic is very huge. And whatever the remaining subtopic in this particular error, or specifically propagation of error in multiplication, quotient, or you can say divide, power, and so, that is important also. So before that, I'm just repeating everything, whatever we done, absolute error we done, the difference between true value and the measured value of the quantity is called the absolute error of the measurement. Okay. Suppose the physical quantity is measured n times. So the measured value A1, A2, A3, the arithmetic mean of these values AM. This is your arithmetic mean, or simply a mean of any particular thing, and that is your formula. So if the true value of the quantity is not given, why we do this? Because if the true value of the quantity you guys don't know, so we suppose the true value is the mean value, and then we find the error, which is in the first quantity, that is del A1. It is known as your absolute error in individual. That is your in second quantity, or you can say in second observation, and that is in the nth observation. And this formula, this one is the formula of your absolute mean error. So this is your formula number second. And if we substitute, or if the measured value of quantity be A and the error in the measurement is del A, then the true value A1 can be written as this one. Or you can write it down in this way, A1 equals to A plus minus del A. Why should I write plus minus? Because the error can be positive or negative in both sense. Clear everyone? We already done this. If you don't know, so go in the previous class. Then we have a two types of error in this. This one is the second, you can say important one, relative or fractional error, and that is the most important also, percentage error. So it is defined as the ratio of the mean absolute error, which is del AM, or to the ratio of mean value, whatever the value we take as a true value of a mean value. So that particular error, or you can say ratio of mean absolute error to the mean value of any particular quantity in any particular you can say experiment, is known as relative fractional. And if you multiply with the 100, so it becomes percentage. So this is your you can say second, this is your formula number 3 is going to be important. Then we done this question also, and this calls numericals related to the error. Now propagation of error basically is what we trying to do that you can say mathematical operations on error. That is the meaning of propagation of error. Mathematical operations. That mathematical sorry that mathematical operations can be addition, subtraction, multiplication, divide, quotient, power, and so and so. Okay, so the remaining multiplication, division, quotient, power are remaining. So let's do this also. What is the meaning of that? Suppose a quantity is you can find a physical quantity which is the sum of two different quantity. For example, perimeter. So perimeter is nothing but 2 into L plus B, right? So in this way we can find it. What is the meaning of that? This is your rectangle. So in rectangle we have a length and we have a breadth. So in this way you can understand x, any particular quantity which is dependent on A quantity and B quantity. So if, or you can say let del A and del B be the absolute error in the measurement of A and B. So del x be the corresponding absolute error in x, means del P is the error you're going to find del L plus del B directly. You can see that here. So this is the first rule, or you can say first rule in the addition of error. Is this clear, everyone? Specifically for Kanishka, because this thing I teach to these students in the previous class. Okay, beta? And that's why I'm doing this in a so much hurry also. Then the second one is propagation of error in subtraction. That is the important one also. If any particular quantity, which can you find it with the help of subtraction? Okay. So then in the same case, either the main important note here is in addition or in subtraction. You can write down again this thing. In addition or subtraction, in addition or subtraction, in both the mathematical operation, in both the mathematical operation, in both the mathematical operations, error is going to be added down. Okay, operations, errors of corresponding values going to be added down. What is the meaning of saying that? Everyone has to keep their camera on. Yes, going to be added down means either any particular physical quantity is going to obtain with the help of addition, or either it is going to be obtained with the help of subtraction. Clear? So in both the case you're going to find that the error in this way it is going to be added down. Error in this way it is going to be added down. So thus the maximum absolute error in x is going to be the maximum absolute error in A plus maximum absolute error in B. As simple as that. And that is your note. You can write somewhere or you can understand this also. Moving ahead. Now from here the things is going to be little bit changed, but here also you're going to see the in maximum general case the error is going to be added down also, but this is a slight different. For example, now you can understand with this quantity a momentum. As we know, momentum P equals to mass into velocity. So whatever the error you're going to find in momentum, that is in general P is m plus del V plus del m into del V. But obviously this third quantity, because error is going to be very small. So suppose the error in mass is going to be 0.001 or 0.12, or the error in velocity is going to be 0.002. So the production, or you can say the multiplication of is very small, so we're going to neglect that. Even we have this the third sum, but due to the small range we're going to neglect. That is what they tell in this scenario. So suppose a result x is obtained by the multiplication of two quantity. Here subtraction is wrong. Okay, production you can write multiplication. Multiplication of two quantities says say A and B. So that is your X, which is A cross B, or you understand from this particular formula also, momentum P equals to mass into velocity. Simple. Okay. So then in this case, del A be the error, del B be the absolute error in the measurement of A and B, del X be the error in the corresponding absolute error. For example, del P is the error of your momentum, del M is the error in finding the mass, del V is the error in finding the velocity. Is this clear, everyone? Okay. So then X plus del X is going to be A plus del A into B plus del B. So that is a formula of A plus B into X plus Y. Obviously, this formula is going to be, you can say AX plus AY plus BX plus BY. And the same formula they open here. So the error del X, A into del B plus B into del A into del A into del B. Why shouldn't I write A into del B here in this? You're going to see in the next page. So dividing equation 2 by 1. What is the equation 2? Here this is your equation 2, which is your, you can say, del X, and here your equation 1, which is the real quantity like momentum. So when you divide this thing, so you get del X by X is del A by A. This is the absolute error, right? So this is your absolute error, or you can say this is your relative error in general, because del X by X is my relative error. Clear? So that is how you're going to get your relative error, and the absolute error is in this way. Clear, everyone? So the formula number 2 here is gives you the absolute error in del X in any particular in this way, or this formula is gives you formula number 3. Formula number 3, this one is gives you in general. Okay, this one is going to be 3B and this one is going to be 3A. Why should I write 3A 3B separately? Because to make it sure, like whatever I said, this is your 3A, this is your 3B, means if we have this del P by P equals to del M by M plus del V by V plus del M in del M into del V M into V. Okay, so again this del M into del V is going to be very small, and that is written over here. The quantities del A by A, del B by B, del X by X are called relative error in values of A, B and X. The product of relative errors in A and B, that is del A cross del B, is very small. Hence it is going to be neglected. So the final version of relative error in momentum, or you can say in the quantities, which particular physical quantity you're going to obtain with the help of product, with the help of this. This is your main thing, product or multiplication. You're going to get this. Is this clear? I know you are not getting that much, Kanishka, I'm talking to you right now. But the next class, what I'm starting, like dimensions, you're going to get. You know something about units, measurement and dimension? Is this going on in your school or somewhere? Good. Okay. So now the propagation of error in product, we done this. So you can again see that hence the maximum relative error in X is maximum relative error in A plus the maximum relative error in B. The maximum percentage error in X is going to be again, because we know that simply percentage error, one thing you stick to your mind, relative error, this particular formula in 200. Okay, then it is going to be very helpful for you guys. So obviously if your relative error is going to be maximum in relative error in A plus maximum in relative error B, so in the same way this particular thing is going to be given to you guys also. The maximum percentage error in X is going to be the maximum percentage error in A. Similarly, the maximum percentage error in B. Clear, everyone? Okay. So till This we done in the previous. I just revise you till now. The next thing is going to be important. Quotient means division. Again, this thing, suppose now we're going to find the velocity, which is displacement upon time. Okay, so this is your physical quantity. I'm just give you a brief physical quantity introduction, which you get from the quotient or division. Suppose the result is obtained by the quotient of two quantities, say A and B. So again, x equals to A by B. This is your first equation. You can mark it out here. And del A and del B be the absolute error in the measurement of A and B, and del X be the corresponding absolute error in X. So X plus del X, how you can, I mean, this is the proper way to write your quantity. In a same way, A plus del A, B plus del B. So X plus del X is giving you A plus del A into B plus del B to the power minus 1. And there is a one formula, or you can say, yeah, expanding binomial theorem. Binomial theorem says that how many of you guys know the binomial theorem? First, tell me this. If you ever listen the name of this thing, whatever I'm saying right now. Anyone? No? You guys don't know anyone? Binomial theorem or any particular theorem, like not theorem even, sequence and series, arithmetic progression, geometric progression. Okay, so don't worry. So clear, sir? It's okay. Till now, is this everything clear? Means I just don't do anything. This is the next step. This is in your denominator. So I can write into this. For example, if there is a quantity V equals to D into T, so you can write in this way also, T to the power minus 1. Anything to the power minus 1 means it is in the denominator. Is this clear till now, everyone? Clear now? Okay. So now the next step is we take out A from in this common. So 1 plus minus del A by A. In the similar way, we can take out minus B, or you can say B to the power minus 1 common. So 1 plus minus del B divided by B to the power minus 1. Okay. So now A by B, because it is into the power of B minus 1. So again, into the power of B minus 1, you can write this way. So this is your formula till now. X plus del X is A by B, 1 plus minus del A by A into 1 plus minus del B by B. Now what is your binomial theorem? Okay, binomial theorem, first of all, binomial series, whatever, what it is. There is a series or expansion, binomial. So beta, binomial expansion is a particular expansion in which you have only two variables. Clear? Or either one constant and one variable. What is the meaning of that? For example, you know this A plus B to the power 2 is A plus B into A plus B. Okay, sorry, because I'm doing a little bit hurry. Teach you another PPT, or you can say that today's class also. But just cope up with me. Okay, A square plus B square plus 2AB. Is this clear to each and everyone? So here we have two variables. So any particular expansion in which we have two variables only is known as binomial expansion, first of all. Now it is very easy. Expansion. Okay. Now it is very easy because it is only power 2. If I am doing this, how are you going to write it down? Tell me. So there is a formula, because you don't know how to calculate this. Even if you're trying to do this, A plus power, is square and then into the power 5. So that is also very typical to calculate. Do that also. You can't able to do this. Clear na? So in so many cases, these terminology is going to be in front of you. So this particular expansion is known as binomial expansion. And how to solve that? Very simple formula. If you have this binomial expansion or series, you can see expansion. Why I'm writing expansion? Because I'm expanding this n. So it is 1 to the power n x to the power 0 plus nc1 1 to the power n minus 1 or x to the power 1. Okay. More importantly, but it is little bit difficult to get to you guys in a very short interval of time. I know this. A to the power n and ncn b to the power 0, which is 1, plus nc, okay, not this is ncn, here it is not going to be anything, nc1 a to the power n minus 1 b to the power 1. Now here what ncn is, the major thing is what I am writing, this nc1 plus nc2 a to the power n minus 2 b to the power 2 plus so and so. In the last I'm going to write plus dot ncn a to the power 0 because n minus 1 n 0 b to the power n. Now what is nc1, nc2, ncn? That is the question in your mind, right? So this is the combination. And now what combination formula? There are two types of formula, combination, permutation. More your mathematics teacher is going to tell you combination or permutation. So with a combination or permutation are two types. For example, you have a box or you have a bag in your hand. Just try to understand physically. And in this you have 5 black ball. Okay, I can make 6. And then 4, okay, 5 pink and then 5 red and then 4 this purple. Okay, so how many balls you have? 6 plus 4 10 and 5 and 5 20. Clear? Now what are the maximum combination you can find? 1 ball of black and 2 ball of pink out of 20. So this is your combination. Means different combination you can get. You need to take out 3 ball out of 20. Okay, in which one is going to be black and other 2 is going to be blue, or you can say other 2 is going to be pink. So this is one combination. Another combination can be you need to take out only 2 balls, both are red. This is another combination. Clear? Only purple ball out, or you can say 4 balls you need to take out, and the 4 out of 4 need to be purple. So this is another combination. Clear? So different types of combination you can make out of these 20 balls whenever you are taking out from the bag. Is this clear? So this terminology is applying in this condition also. What is condition here? I have this much power. So in this power, the first combination is A going to be the power n and B is going to be 0. First combination. Then NC1. NC1 gives me some formula. There is a formula. Don't worry about the formula right now. A to the power now, because I have only 2 balls in this condition. In this condition, this is my bag, brown ball and red ball only. Clear? So now from this 4, you need to convert your imagination into 2. So suppose I am taking out 2 ball. So 2 out of 2 ball are can be brown. Clear? The another combination I am taking out 2 ball. 1 ball is going to be, you can say, brown. Another ball is going to be red. In the third combination, the 2 out of 2 ball going to be red. Is this clear now? So in this way, if I have n number of combination of n number of power to expand this, so all the balls can be brown. First condition. All the you can say okay, this formula you are going to understand that. A plus B square, A square plus B square plus 2AB means either all the balls, or you can say 2 balls are going to be brown, 2 balls are going to be red, one ball is going to be brown, one ball is going to be red, and in the same out of the box means the first ball you pick out, it is going to be brown and then red, and then red into brown. So AB plus BA gives you 2AB. Is this clear? So that is the magic, or that is the way we can find this A plus B in a real life scenario. So now I'm saying instead of 2 times, you need to do this thing. You need to play this game out of 2 only 12 times. Find this. So to calculate this, we do this. All the 12 balls are going to be, you can say, brown only. In second case, one ball is going to be brown, another going to be red. Third, uh, two balls going to be brown, another going to be red. Fourth, sixth, seventh, eighth. In this way, you can give 12 powers, or you can say 12 different combinations. Is this clear? The combination thing. So in the first scenario, I have 1 to the power n, x to the power 0. In the second scenario, 1 to the power n minus 1, x to the power 1. In the third scenario, then I can write this condition 1 plus x to the power n 1 directly plus nc1 x to the power 1, because 1 to the power anything 1. Clear na? Plus nc2 x square plus dot 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 dot. Now here ncr is the n factorial n factorial or n minus r factorial. Now you are guys thinking, sir is writing so many formulas in a single slide. Okay, what is factorial then? Sorry, but I need to write it this thing. N factorial is nothing. Suppose, okay, not n factorial. 5 factorial is nothing. 5 into 4 into 3 into 2 into 1. That is the meaning of factorial. This is the sign of factorial. Okay. Meaning of this is you need to multiply till 1. Clear everyone? So if I'm writing n factorial, so the formula of n factorial is n into n minus 1 into n minus 2 into n minus 3 dot 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 into n minus n okay, n plus 1. What is the meaning when you do that? Not this one, n minus 1. Okay, till 1. You understand in this way. Till you get 1. So this is the n factorial. Now you can put n anything. Is this clear? Like I put 5. 5 minus 5 first of all. 5 minus 1, 4. 5 minus 3, 2. 5 minus 3, 2. And then 5 minus 4, which is going to be 1. And then 1 directly. Clear? So that is your everything. Now why should I teach you this much? Because this is have one special case when x is very less than 1. So you can write 1 plus x to the power minus 1 equals to 1 x to the power. You can say this particular. I mean this minus plus is going to be 1 minus x. Because every other power, you can get every other power also, x to the power 2 minus x to the power 3 using this same terminology. This one 1 to the power n and so and so, but every other particular powers is very less. Clear na? Because x is very less than 1. So if suppose you can say x is 0.0005, square that, so that is going to be 25 into 10 to the power minus 6. So I can neglect it. So I don't need to write any particular terms after this. Clear? The general formula is going to be the remain same. For this condition, I can write 1 plus x to the power minus 1 approximately equal 1 minus x. And that is why I teach you everything. Now it is clear. Is this clear now everyone? I teach you one important thing here, binomial theorem, binomial expansion. So binomial expansion is nothing. Bio means 2. Okay, binomial expansion is a kind of expansion. For example, you have a plus b to the power 5, x plus y to the power 5. You can write 105 also. Suppose how it is going to be used practically, mathematically. Suppose you need to find this 105 to the power 10. Do that. Obviously, you can't do that. Now you can do that. Clear na? Second case, if it is 98 to the power 12, or you can say even 6 only. Either this is the way you can say 98 and then power 3 cube. This one way also, then directly 100 minus 2 to the power 6. So practically or mathematically more we here use here. Sir, is it like probability of combination? Yes. Okay. So the main agenda, again coming back to this topic. Sorry to teach you that much math. It is necessary, but so x plus del x, a plus b, 1 minus plus. Now y minus going to be as you can see here plus minus, because I am going to multiply this minus into here, so that is going to be minus plus. The terms containing high power of del b by b, the values of higher power of del b by b are very small, as I can write del, I mean this higher power of x square, x cube is very small and hence can be neglected. So that is your expanding binomially, or you can say binomial expansion. So x plus del x, this is your main thing, error, which is you can write 4 equation, a by b, 1 minus plus del b by b plus minus del a by a minus plus into both. Clear this thing? Is this clear, beta? I know it's hard to digest, but this is the way you need to get it. There is no other way. Just for single this word, I can skip that, but there is no other way to understand this, at least at this particular point. Now the quantity del A into del B, this is del B, A by B is very small. Again, as you can write, del A into del B is neglect, or you can say negligible. So we can neglect that. Okay, hence can be neglected. So del x, sorry, x plus del x equals to a by b, and to this terminology, and then again solving this particular whole thing, we can get even in the quotient. The main thing is relative error in A is going to be the relative error in B plus relative error in B. Is this clear? Okay, so even if you are doing product, even if you are doing the quotient, so the main thing come back again after each particular calculation, error is going to be added down, and that thing I write it down in the previous class. Okay, when you go through the previous video, so you can understand. So propagation of error in quotient also, the quantities of del A by A, del B by B, del X by X are called relative error in the values of A, B and X. Hence the relative error in X is maximum relative error in A plus maximum relative error in B, and that is your main important thing. Okay. Is this clear, everyone? Good. Okay, now propagation of errors in product of powers. Now what is the meaning product of powers? Suppose x a to the power n. You have some this particular kind of formula, or a can be anything. Clear? Simple understanding, area is length square or pi r square. Pi is a constant thing now. So r square, length square. Clear? You can understand this way. Or area of a circle is pi r square. So pi is a constant, r to the power 2. Here instead of a to the power n, you can understand r to the power 2. N can be 2 also. So in this case, what is the what is your particular error is going to be? So again the same thing, del a be the absolute error in the measurement of a, and del x be the corresponding absolute error in x. If I'm talking here, so del a is the corresponding error in area, which is a, or you can say, I cannot write a here, the power n. Instead of n, I can write 2 here, because my n is 2. Here, my power here is 2. So x plus del x, a to the power n, I mean I can take out r to the power 2, 1 plus minus del A by A, which gives me absolute error, or you can say relative error in A to the power n. Now again expanding binomially, or you can say binomial expansion, binomial theorem, x plus del x a to the power n, 1 plus minus n del A by A plus minus terms containing higher powers of this. And again higher powers of this is going to be neglect. Clear? The same thing, even if you can write del A into del B, or del A square, which is del A into del A, negligible. 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 Okay, so in both the cases, both the powers, or you can say both the things, is going to be 0 or negligible, very very small as compared to 1. Clear? So the same thing till now we are seeing here. So in the next, the values of higher power of del A by A are very small, hence can be neglected. So again solving that is the important and not the same case as we seen till now. So what you can see here, and from using this particular formula you solve one question also. If you can say percentage error or relative error, if relative error in length is 2%, right? Is 2 or is, you can say, is 2 or 2%. Then error in volume. Then error in volume. How you can find this? As we clearly know this, volume is L to the power 3. So error in volume del V is nothing but 3 times of error in L. So where from this particular formula comes? You find it down now. In the last class assessment, you do this thing. Everyone, right? Is this clear? Samyukta, Bhuvna, Pranav, Pranay Dubey, or Shrita, Mukeshwaram. Clear na beta? In the last class, you did this thing. And if you don't, so from this particular formula, we find this. So again, absolute error, which is, or you can say relative error del x by x, or you can say del v by v in volume, is nothing but 3 into relative error in length. So here, this is your relative error in volume is nothing but 3 into relative error in length. And the same formula with the number you can see in the above. So that is again an important formula. Clear everyone? Good. So now propagation of error in product of you can say in the product of power of observed quantities del A by A and del x by x are called relative error in the value of A and x. Hence the maximum relative error in x is nothing but nx. Maximum relative error in A. So consider a general formula. Now this formula is going to be very important. Why should I write this? Because maximum number of times we find the error in, you can say, particular quantity. Simple quantity I am taking right now, density. Density is beta mass per unit volume. Clear? So you can write this thing, mass to the power divided by L to the power 3. So now here mass can be replaced with A, it is power 1. L can be replaced with C, which is power 3. So I need to find the error in density. I can write D. So error, or you can say percentage or relative error in E, error in mass plus, the error is going to be plus always. The major thing is this. Okay, or 3 del L by L using this particular general formula. Is this clear to each and everyone? The product of quotient formula I apply, and we can prove that this one also. Is this clear now? So in this way you can find the error in density. Is this clear each and everyone? Please let me know right now because that is important thing. That's why I'm spending 1 hour. See, I can do that in the previous class also in 10 minutes or 15. But it is going to be important. That's why I am teaching separately, spending 1 hour. Because I know I can teach this particular class PPT in the next also because it is your chapter assessment. Clear? Or I know I can finish that also in 1 hour. And taking a little bit more time with you. 5 minutes or 10 minutes, not more than that. Is this clear, everyone? Everyone. Bhuvana, Samyukta, Mokeshwaram, Shreta, Pranav. Leaving this new girl today. Because she thought sir teach me so fast. But I'm not teaching in this fast way. I leave this because of this highly important topics. Clear, everyone? Okay, believe me, I don't teach in this fast manner. I I just cover my syllabus from the previous class. So that is the way you can find. I'm just writing simply density. We have so many formulas in which you're going to find the different things also. For example, I can give you 6 pi neta RV, and neta is something also. Okay. Uh, Stokes law, there is a formula in fluids you're going to find, and there is a force in the fluid. Fluid is any particular thing which can flow continuously. 6 pi neta RV. Okay, neta is a constant, R is radius, and V is what? Volume. So if you're going to find this 6 pi, neta is a constant, so leave this. So here till now we don't need to worry. R into again L to the power 3. So this particular formula can gives me A to the power 1, B to the power 3. Clear? And we have so many different formulas also. Clear na everything? Like how this quantity is going to be related down. Okay. So if any particular physical quantity of yours is x, a to the power b, sorry, a to the power l, b to the power m, c to the power n. So to find the error in x, or you can say absolute error in, relative error in x, del x by x, just multiply the power into the error or relative error of a, multiply it to the power into the relative error of b, multiply the power into the error of c or relative error of c, and add it down. If it is in denominator, if it is in numerator, you don't need to worry about it. Because till now what we are seeing, either it is quotient, either it is multiplication or a product, either it is a addition, either it is a subtraction. In each terminology, in each particular mathematical operation, whatever the physical quantity I obtained, error is going to be maximum and they are added down. So here they are going, I mean, in this way or in this particular formula, they are going to be added down also. Clear, everyone? Okay. Is this clear? Good. So now at a glance, that is whatever we do. So this is the important points. Okay. Already it is written down. So just quickly, propagation of errors in mathematical operations. If x, a plus b, then the maximum possible absolute error in measurement of x will be del x, del a plus del b. If it is the subtraction, then the same thing. If x by, if x, any particular value is a by b, then the maximum possible fractional error or relative error is again the addition. If you have any particular physical quantity which is a to the power n, or any particular other variable to the power n, for example volume, length, okay, or any particular other terminologies also, or you can say kinetic energy. Kinetic energy is what? Half is a constant, mv square. So here kinetic energy directly proportional to v to the power 2 and m to the power 1. So this is your general quantity k, m to the power 1, v to the power 2, that's it. Okay, so in this way you can find the next one. So again, for any particular quantity which is x, a to the power n, so error in x or absolute error or fractional error in x is n to the power error in a. If a to the power n, b to the power m, c to the power p, so this is your, this one is very important. Okay, For JE, this is your very, very important, and this one also, D. Okay, very, very important. Moving ahead, if log e to the power a, then the maximum possible fractional error will be del x by x, 1 by x, del a by a. Better log terminology you need to ask to your teacher, mathematics teacher. Because if I'm going to explain like binomial, so I need another one. You can say not 1 hour, but at least 15 minutes. So for right now, you need to remember. I don't say this thing, but for right now, I need to. Okay. So this is your question. Try this, do this, and then we are going to find, and then I am going to give you 5 minutes break, and then after 5 minutes break, we start the main thing, dimensions. Okay. You read so many mathematical operations of error. So these, the two resistance R1 and R2 are connected in series, and I hope and I believe you get you get good marks in your class 10. So resistance in series is going to be the directly added down R1 R2. So you need to find the resistance in net equivalent resistance, or you can say R total is R1 plus R2. And believe me, for NEET even or for JE aspect, that question is no one is going to ask because that is so much basic, very basic, even basic from basic. Okay, whatever the formula I write it down in the previous pages, you just need to think and tell me the answer. Do that quickly. And just give me the R total with the error. Then I'm going to delete this and not delete. I'm going to add another PPT for you. Tell me quickly what is the correct answer. That is so easy. You don't need even to write anything. That much easy. If you understand so. I give you a hint, resistance in series is going to be added down directly.
That 250 plus minus 5.
Exactly. 250 plus minus 5. Everyone got it? Clear na? You, Samyukta beta. Clear? You are not audible. Turn on your audio, then speak. Or you are writing. Okay, good. Is this clear, Kanishka? Okay. So as we know, error in any particular terminology is going to be added down. So R1 is 100 plus minus 3. R2 is 150 plus minus 2. So directly add these two quantities. So R total is 250 plus minus 5. Simple. Okay. In the same sense, this is another. T1 is this. T2 is this. Calculate the temperature difference. So again in the temperature difference, this is 20, this is 50. So 30 plus minus 1. Why it is plus minus 1? Because either it is difference, either it is multiplication, or either it is addition. In all the four simple mathematical operations, in power it is going to be multiplied with the power only, or in any particular combination of power it is going to be multiply the power plus another term. But in addition, subtraction, multiplication, or divide or quotient, in a simple four mathematical operation, your error is going to be added down. So here always T1 is this, T2 is this. So net temperature, or you can say temperature difference, T2 minus T1, which is 50 plus minus 20 plus minus. So error is going to be added down. This is going to be this. So the final temperature 30 plus minus 1 degree Celsius. Is this clear, everyone? Clear na? Good. Okay, let me see. I can add another or not. Yeah, I can. Oh my God. So this is the main class we going to discuss in this. So three things are important, or you can say dimensions. What are our dimension? Basically, we are going to revise from the very basic physical quantity, then fundamental quantity, then dimensions of that, and what is the practical application to write the dimensional formula. So basic three form applications. First is to write the left hand side and right hand side of any particular equation. Is it correct or not dimensionally? Second thing, if you don't know the answer, that is the trick. If you don't know the answer, so whatever the question or whatever the physical quantity is they ask in an examination, so you can find it out. Another application is homogeneity. What is homogeneity? As you know, you can add and subtract same types of quantity. You cannot add apples with guavas or something if there is a counting going on. Okay, suppose there is a simple example. There is a basket or there is a bag of fruits in which you have n different kinds of fruits. So only if I'm saying count how many number of you can say mangoes in that. So if you find first time mango, in the second time apple, in the third time any particular fruit, in the fifth time again mango. So then you are saying now I have two mangoes. What is the meaning or physical meaning of saying we can add or subtract only same type of quantities? Clear? So that is the principle of homogeneity. Means dimensionally we can prove that we can add or subtract an same type of physical quantity. So this is a recall. Read this, and this is a recall also. I'm going to give you this also. Okay, so just read this, and there is a 5-minute break, and then after this I'm going to teach you. Clear? This lecture is going to be a little bit I'm saying revision more, or whatever the things are very less, but these I mean whatever the subtopic you find in this particular class are less in number but more significant, more important to understand any particular thing. And this particular lecture is going to be more important in the previous two, not three, because errors and this dimensional formula, that is more important as compared to the units and physical quantities. Because most of the time, if you are lucky enough to get any particular question from this, so you get, I'm talking in from both the aspect like JE or NEET. So if you are lucky, why should I am saying lucky? Because this is just the beginning for physics. A more complicated or more complex, or you can say a moderate or hard concepts or topics is waiting for you guys. So if you are lucky, so from this particular first chapter you get one or two question from the last two class like errors, and then this what is this particular class? Dimensions and application of dimensional analysis. Clear? So read this. Why this mic going? Just a minute. Okay, so this is we already know there are types of error. Error is what? Okay, just give me a second. So recall means what we already done in the previous class. Okay, error is the difference between true value and the measured value, and then quantity is known as error of measurement, and then types of error. So we in a great detail in the previous class, in the previous class, error in general, the error in measurement can be broadly classified: systematic, what you know; random error, what you don't know, or you can say human error, or you can say environmental error, or instrumental error also. And then least count error. Least count error is what, beta? There are two types of devices like vernier caliper, or and the another thing is screw gauge. So the least count of any particular instrument is the minimum bare value or minimum value which you can find from that particular instrument. For example, meter scale. So with the help of meter scale, we can find only 1 mm, 1 by 10th of centimeter. Clear? So suppose this is your meter scale or centimeter scale, 15 centimeter scale, starting from 1 centimeter, 2 centimeter, 3, and so and so and so till 15 centimeter. Then this 1 centimeter even it's divided into 10 in this way, 5. So the minimum thing you can find with 15 centimeter scale is 1 mm. Clear? And that is the LC, least count. So in least count also there is an error, least count of instrument. So that can be positive, negative, 0, which is minimum value. Minimum value. Okay, is this clear? Minimum value of that instrument. And there is an error. Why? So if if you are using that particular scale so many times in drawing a straight line and so this 1 or 2 mm is going to be removed. And when this 1 mm or 2 mm is going to be removed, or it is not visible clearly, so the length is not going to accurate with this centimeter scale. Simple, you understood? So this particular error can be positive if it is you can say broken from this particular small side, from this particular side, or if it is going to be removed. So that is going to be positive, negative, 0. So there are 3 types of errors: positive, negative, 0, or these 3 types of error can be LC error also, least count error also. Moving ahead, units. We already done this thing. So unit is a measurement to write any particular physical quantity. To write any particular physical quantity, PQ, we need this thing, N into units, where N is a numerical value and units are the base. Okay. So every measurement means beta here physical quantity. What are we are going to measure? Physical quantity. What is a physical quantity? Any particular physical phenomena, physical change happening in your surrounding, and you need to write it down. Simple thing. Walking is a physical quantity in which you need to mention distance. Clear? So these are general physical quantity. Like kicking a football or a ball is a physical quantity or a physical phenomenon in which we need to find the force. Simple. So every measurement has 2 parts. The first is number and the next is unit. So this Q, which is a quantity, or you can say physical quantity, is NU, that I already write it down. For example, length of an object 100 centimeter. The number expressing the magnitude of a physical quantity is inversely proportional to the unit scale. If N1, N2 are the numerical values of a physical quantity, corresponding units U1, U2, then N1 U1 into N2 U2 is going to be equal. For example, 2.8 meter is going to be 280 centimeter. In a same sense, 6.2 kilogram is going to be 6200 gram. Why so? Because 1 kilogram is 1000 gram. In a same sense, 1 meter equals to 100 centimeter. So there are different kinds of quantities or units also. Level physical quantity, then we have fundamental units, derived quantities, then we have derived units, then we have supplementary quantity also, which are dimensionless or which are unitless. Clear? You know what are the supplementary quantity? Everyone. There are 2 types of supplementary quantity. First one is angle, second one is solid angle. Angle is nothing but length upon arc upon radius, and solid angle is nothing but area covered by this particular solid, or you can say radius square. I teach this thing in the previous class, so I know this at least. Okay, moving ahead, this is your fundamental unit. So physical quantity, then unit, then symbol. We already done this thing. So just quickly see this, and if you want ask me, if you want anything to ask me out in this, so you can go ahead. So just underlying the main things, the quantities that are independent of other quantities are called fundamental quantities. The units that are used to measure these fundamental quantities are called fundamental units. And this single table is very important to start this chapter at least. Physical quantity: length, mass, time, current, thermodynamic temperature, intensity of light, quantity. Okay, what are the dimensions? We going to understand in the next classes. But in general, these 4 gives you dimension. Length have capital L, mass have capital M, time has capital T, and electric current sometimes capital A or I directly. With the help of these, we're going to describe any particular physical quantity or any particular physical formula. For example, x, which is a displacement, ut plus half at square. So obviously the left hand side is the displacement, which is going to be L1 m0 t0. What is the meaning of saying that? Dimensional formula of length, or you can say distance. So we need to prove that right hand side is going to be the same thing. If the right hand side is not give me this m0 l1 t0, so this formula, this equation is not correct, dimensionally at least. Clear everyone? So that is the use of dimension. What is a dimension? We're going to cover in a minute. So that is supplementary quantity. We know this thing. If you don't know, so it's okay. In the previous class, in the first class, I teach this thing in a very great detail. Clear everyone? Okay. This is derived quantity. We done this thing also. So the quantities that are derived using the fundamental quantities are called derived quantities. For you beta only, Kanishka, I am telling you this. Maybe you think also I am just running like a Usain Bolt since the beginning of this class. So I skip, this running for a minute right now. What is this derived quantity? Whenever we have 7 fundamental quantities, so any other particular physical quantity, for example, starting with very basic, acceleration is velocity upon time. Okay, change in velocity upon change in time, simply, where velocity is displacement upon time. So this velocity is a derived quantity because it can be derived with the 2 fundamental quantity. One is length, another is time. Then this acceleration can be derived with the help of another 2, which is derived one and the fundamental one. In a same sense, force. In a same sense, the force F equals to mass into acceleration. So that can be derived from 3 quantities, or you can say 2 in general, mass and acceleration. And acceleration is can be derived with the velocity and time. So in general, there are these kind of quantities derived. Example, very basic: area, meter, square meter, meter square; volume, cubic meter, m to the power 3; speed and velocity, meter per second; this acceleration, meter per second square; wave number, reciprocal of meter, 1 by m; mass density. Okay, let's do this also. Mass density d, which is mass per unit volume, that is known as mass density, kilogram per cubic meter; specific volume, cubic meter per kilogram. Okay, reverse of this. In a same sense, you have momentum. In a same sense, you have a force, work done, power, so many things. Okay, other than 7 fundamental quantities, every particular quantity leaving 2 behind, like angle or solid angle, every particular other quantity come under the category of derived units or derived fundamental quantity. Clear? Good. So this is derived unit. Current density, area per meter square; magnetic field strength, area per meter; amount of substance, concentration, mole per cubic meter; amount of substance, concentration. So this concentration word is more important because amount of substance, which is mole, is a fundamental quantity. So mole per cubic meter. And luminescence, candela per meter square. Okay. Luminescence density is the correct word here, because luminescence or okay, luminescence is correct. Luminescence you can derive or understand. Luminescence is intensity per unit area. Intensity of light per unit area. Is it clear, everyone? So that is your luminescence. So that is also derived quantity. Then dimension. So this is the main thing what we need to discuss today. Sorry, I'm doing this very late. Okay, so what is a dimension? Dimensions of a physical quantity are the powers to which the fundamental units are raised to obtain 1 unit of that quantity. Beta, do the Hindi or Tamil or whatever your mother tongue is, that meaning. I just know this thing. What is the dimension of a physical quantity? We know this is MLT and sometimes I and A. Okay. M stands for mass. L stands for length. And then T stands for time, and I or maybe A stands for current, electric current. Because current is in general some different meaning also, electric current. So to represent any particular formula, any particular physical equation or any particular thing, whenever the power is going to be raised, suppose m to the power 1, l to the power 2, 3, I mean t to the power something. So this particular terminology when we write in this MLT form is known as dimensional formula or dimensional analysis. Very basic thing I'm going to give you guys right now, dimension of force. Dimensional formula of force. Any other thing you can read it out till now. Dimensional formula of force. So, okay. Please anyone tell me what is the units of force, because formula I'm going to write MA. Please tell me. Kanishka, you tell me what is the unit of force? If you don't know, so it's okay. Newton. What is 1 Newton? You tell me, Mukeshwaram beta. Unit of force. I'm asking to you. Yeah. Okay. See, force is mass into acceleration, and that can be understood as a Newton. So tell me what is 1 Newton? I'm asking to you, beta Mukeshwaram, what is 1 unit? Sorry, Newton. 1 Newton of force. This is very easy, guys. And I hope other than Kanishka, please everyone know this. What is 1 Newton? You're right. You know na, everyone. You can speak out so we can.
10 to the power 5 die.
This is Ashrita, right?
Yes, sir.
Beta 10 to the power 5 dyne, I understood. But I'm asking what is 1 Newton of force. So 1 Newton of force, instead of saying that, because it is different units in general, whatever you are saying, telling me right now. You tell me, Samyukta beta. And please either write it fast or either tell me with the help of your mic or this audio. Yeah.
1 kg meter per second.
Exactly. So 1 Newton of force is 1 kilogram 1 meter per second square. What is the meaning of saying that? When mass m is 1 kilogram and acceleration of that object which have a 1 kilogram mass is 1 meter per second square. Okay, so that is your 1 Newton of force. Means when object of 1 kilogram is moving with 1 meter per second square. So how you can write it down? Because kilogram is mass. So m to the power 1, meter is length, L to the power 1 divided by time, T to the power 2. So exactly M1 L1 T to the power minus 1. Is this clear? So this is your dimensional formula of force. Clear everyone? Clear na? You beta, Kanishka, Bhuvana and Samyukta, Mukeshwaram also you. Clear? Good. So let's go back to this. Then dimensional analysis. Dimensional analysis is the practice of checking relation between physical quantities by identifying the dimension of the physical quantities. These dimensions are independent of the numerical multiply. What is the meaning of that? Numerical multiples. For example, I write 2 Newton. So then again 1 Newton or force have a dimension m1 l1 t minus 2. So either you write 2, either you write 20, that is a constant thing. So that is not going to work it out. All the quantities in the world can be expressed as a function of the fundamental dimensions. And we prove that whatever we are writing, that is you can say fundamentally correct with the help of dimensional formula. Is this clear? Clear na everyone? Like what if you are giving the equation v equals to u plus at. So in both the side, the dimension is needed to be of velocity, which is L1 t minus 1, length upon time, distance upon time, displacement upon time. So that is your dimensional formula. So as you can write it, see this, if Q is the quantity or unit of a derived quantity represented by Q, so then it is your dimensional formula. So I already given this, I don't need to, you can say explain this again. M a to the power b, L to the power b, a to the power m to the power a, L to the power b, t to the power c is called the dimensional formula, and the exponents a, b, c are called the dimensions. Example, the dimensions of force again, like we already done this, so that is easy to understand. M1 L1 t minus 2. So the dimension of this particular force is 1 t minus 2, or you can say M1 L1 t minus 2. Clear? Is this clear? So in the next page, let us look at the sum dimensional equation, and the next page is going to be very important. Either you understand, either you learn. I am repeating, don't learn this. Never learn physics. Clear? Good. See, a few important ones here mentioned out. Physical quantity, area, length into breadth, L into L, because breadth is also a length. Again, this in this way. If you want to find the area of this, so that is your length, that is your breadth. So area is going to be, I'm just writing this. After that, I'm not going to write anything in this page at least. So that is, breadth is also a length, or you can do this meter into meter. Meter is square. So meter is a length. So then area have a dimension, either directly L2, or either this way you can also write M0 L2 T0. Anything to the power 0 is 1. Clear? So that is why either you can write it down directly L to the power 2, or either in this way. Now after this, okay, if something is, I feel it is necessary to explain, then I'm going to. So density is mass per unit volume, mass is M, volume is L to the power 3. Wait. Arey yaar, this is not. Wait a minute, beta. This is clear? Visible? Or, yeah, this is clear. I don't need to make it extra here and there on my pen. So acceleration, change in velocity upon time. Velocity is Lt minus 1 divided by t, Lt minus 2. Okay. So check here if you find something that is not correct. So let me know also. Force, mass into acceleration, mLt minus 2. 1 you don't need to write it down. Linear momentum, which is mass into velocity. So velocity, you know, Lt minus 1, mLt minus 1. Pressure, force upon area, mL minus 1, t minus 2. What is this? I mean, how we can get this? As we know, pressure, which is force upon area, or you can say force and L to the power 2, because area has L to the power 2, or meter is square. Clear? You find it down now, L is square, and this is M L t minus 2 divided by L to the power 2. So you can automatically get M L minus 1 t minus 2. Pressure. Clear? And don't feel pressure if you are clear the concept. I mean, if you are trying to clear the concept since the beginning, you don't need to feel pressure for any examination, at least in physics. Clear? Good. Pressure done. Then universal gravitational constant. As you know, according to Newton's, there is a force applied in between two masses, which is directly proportional to the mass square, inversely proportional to the radius or distance between them. And then this constant is nothing but F directly M1 M2. Okay, not in this way. F is G M1 M2 divided by R square. So from there, G is a gravitational constant, force into R square divided by M1 M2. Clear? So we know the dimension of force, we know the dimension of R square, which is L2, we know the dimension of M square, which is M2. So putting that everything, L. Okay, this is not correct. 3t is not correct here. So I can erase this and I can write the actual. The actual thing is m to the power minus 1 L to the power 3 and T to the power minus 2. M to the power minus 1, L to the power 3, T to the power minus 2. This is correct or not? Tell me. Check and this tell me, is this correct or not? Do that. For a minute. Correct now? Just what you need to do, you need to put the dimension of each. Like G is F is M L T minus 2 into L2 divided by M2. Clear? Clear na till now? Because M is square. So M is square M, M minus 1, L1 and 2, 3, T simply. So why are you waiting for this much? Tell me, is this correct? Correct na? This one? Correct. Work is force into displacement. So again MLT minus 2 into LML2 T minus 2. In a same sense, energy is going to be ML2 T minus 2. And from there, I'm going to teach you in the 6th chapter maybe, work energy theorem. Work can be transferred or converted into the form of energy. As you can see, the dimension formula of both are correct or same. ML2 T minus 2. Okay, or one basic example I can give you right now also. Okay, just because I'm always did this whenever I teach this work and everything. See, in the smaller classes, in the 9th class, 10th class, we see on when we learn, potential energy is different than work, but it is not. Potential energy is defined as the work done to do something, or potential energy, you can say when work is stored in the form of energy. What is the simple basic example? See here. Suppose this is your table. Okay. And in a minute, you're going to understand right now. Just be with me. I know I'm not teaching the main thing, but I'm teaching something else because I love this. Okay, suppose this is your table. Okay. And in this particular table, there is a remote. Okay. And this remote is fell down. Or any kid at your house, throw it out. Okay. Wait just. And then you're going to understand. This is your remote. So if you try to bring this remote again to this particular height, and this is your ground level, one last, that's it. This is your ground level and this is your height of this. Okay. So what is the work done to put this particular remote back? Work done is force into displacement. Clear? Clear na? Force into displacement, and more accurately, force into displacement, because it is a scalar product, which is force into displacement into cos theta. Clear? Till now everyone understood? Okay. As you can see, what is the force on this when you try to keep it back? Gravitational force, mg. And what is the distance? Height, which is h. But the gravitational force, which is F, and the height, which is displacement, both are in opposite. So angle here is 180 degree. Clear? Clear till now? See, suppose this is ground and this is my table. So I need to hold, I need to, you can say, apply a force on the corresponding of gravitational force, which is mg, and I need to bring it back. So the displacement is in upward direction and the gravitational force in the downward direction. Clear na this thing? Okay. So the theta is 180 degree, and if theta is 180 degree, so cos theta, or which is you can say cos 180 degree, is -1. Clear? Clear everyone? Good. Then work is mg into displacement is here h, and cos theta is -1. Is minus of mgh. Clear? Understood? Now I'm saying my potential energy is nothing but work stored or stored work done. I mean, you can say whenever you do some work, so that is stored. So when something is stored, so it is going to be in a negative sense. What is the meaning of saying this? Suppose there is a big jar. From this big jar, you pick, there are n number of toffees, candies, and you need to store 5. So you pick 5 and you put into the small jar to take in your school or somewhere else. So what are you doing? You storing it means you subtracting from the bigger one. Clear na? That is the meaning of store. If I'm saying potential energy is nothing but it is the stored work done, or it can be derived or it can be stated the energy when work done is stored in any particular system to perform energy, to do something work afterwards. Clear? So you are storing the candies here. Suppose 5, these are 20s, and you are storing 5 only. So now here remaining is 15. So what you are doing basically? Negative subtraction. So the potential energy is nothing but negative of work done. What is work done here? Minus of mg h. So that is your potential energy. I hope with this example you are clear and you are clearly understood that potential energy is nothing but the stored work done in any system. Is this clear now? Is this clear, everyone? Maybe this is going a little bit beyond, but I know this is the better, or you can say this is the best way to understand potential energy. You can do any particular system. I'm just telling you for the mgh formula. Clear? So that is why work done and kinetic energy, because energy or kinetic energy and potential energy, every type of energy is the same dimensional formula. Clear? Good. I hope you clear the concept of potential energy also here. So this is your first question. Do that. Which of the following is an example of a fundamental unit? Very easy. Here fundamental unit are 2. It are ampere also, na? Let me check it out. More than one. This is your MSQ. More than one. Which of the following is an example of fundamental unit? Kelvin also. Ampere also. Okay. So, okay. Move to the B and C. Yes. But in the given answer, only C is given. I don't know why. But the correct answer is you and we both know B or C both. Okay. If you work hard enough, so you get these kind of question also. In JEE Advanced, why should I say this line particularly? Because this kind of MSQ, multiple selective question, you can find only in JEE Advanced. Okay, so for this, you need to clear it out JEE Mains first. Clear? What is the message in single line? If you work hard enough, again I'm saying that, so you get these kind of question also. I mean, not this basically, this is very basic, easy, but MSQ. The main thing is MSQ, multiple selected, multiple selection of choice, base question. Okay, remove this. Do this. Which one of the following represent the dimensional formula of acceleration? Very easy, very basic. Everyone I answer. I need answer from everyone. Correct option of this. And please don't do mistake here at least. Then I think after teaching you guys 1 hour 7 minutes, not 2 hour 7, not 2 hour, 1 hour. How much time I teach you guys? 25 minutes remaining from 2 hours. So, or you can say 20. So at least 100 minutes. Everyone B. Good. Okay, I don't need this B and C. Okay, so now applications of dimensional analysis. I already teach you. I mean, I already let you know. Just go through this. Dimensional analysis is an important aspect of measurement, and it has a many application in physics. Dimensional analysis is used mainly because of 5 reasons, which are first. Okay, so this one is your first, to check the correctness of an equation. Okay, I mean the left hand side and the right hand side, you need to prove or you need to check it is a correct or not, or any other physical relation based on the principle of homogeneity. Again, what is the principle of homogeneity? You can add or subtract the same type of quantities. I mean the left hand side and the right hand side of the both the formulas need to be dimensionally correct. That is the meaning. Simple. There should be dimensions on the two sides of the equation. The dimensional relation will be correct if LHS and RHS of an equation have identical dimensions. If the dimensions on the two sides are incorrect, then the relation will also be incorrect. See, the constant and everything may be changed. For example, this again, ut plus half at square. Okay, and you can say other this thing, because this is simply energy, or you can say total energy. Total energy is kinetic energy plus potential energy, which is also energy. So half mv square plus mgh. Clear? Clear na? So in both the you can say left hand side, right hand side, this is your LHS, this is your left hand side, and this is one is your RHS. So in both the side, the dimensions need to be correct. Clear? Good. Huh. So the second formula or the second important thing is, that is the first one. Dimensional analysis used to convert the value of a physical quantity from one system of system to the another. Okay, we have three only: MKS, CGS, FPS. We don't use FPS here in general in an Indian system. MKS stands for meter kilogram second. CGS stands for centimeter gram second. FPS stands for foot pound second. Okay. Rest every other fundamental quantities are remaining same. So if you need to change from you can say smaller to higher, higher to smaller, any particular other quantities also, so that you are going to use. It is used to represent the nature of physical quantity. Like what particular quantity is this? Okay, and there in this particular third point there is a trick. And what trick I am going to tell you also. The expression of the dimension can be manipulated as algebraic quantities. What is the meaning of this? This is one important also. Okay, see, again with this equation of motion, because you know this, I can write this one also, ut plus half at square, which is the correct one. Even I can write this one also, 3 by 2 ut plus 2a t square. This one also correct dimensionally, isn't it? So that is the meaning of manipulated as algebraic quantities. Means you cannot prove only and only with the help of dimensional formula the given equation is correct or not. So two things I'm going to tell you here. First thing, a trick. What is the trick? Simple basic thing, not you can say rocket science. If you don't know the answer, any particular MCQ, and they ask about the momentum, suppose, but you know the dimensional formula. So the dimensional formula of momentum is mv, which is mlt minus 1. Clear? So from the given option, you just need to find which particular formula is the same formula of mlt minus 1. Rest any other three formulas you need to leave, because there is a MCQ. In MCQ, this is going to be an MCQ only. Okay. Multiple correct choice in which one option is correct. In MCQ question, we or you can use dimensional analysis dimensional analysis to guess the answer. I'm not saying you need to do this every time, but if you don't know, anytime. Okay, using this, the guess is going to be strong. The first thing, trick. The second thing, what I'm going to write it down for you guys. This one. What is this? Dimensional analysis, or you can say dimensional formula. Dimensional formula did not. Dimensional formula did not give or prove the correctness of the formula or equation. The correctness of the formula or physics or any physical equation. Correctness, yeah, of any equation or formula. Clear na? We have one more, you can say very important example like this one. Like time period of a pendulum is 2 pi under root L by G. This is your correct formula. Clear? But if you try to solve this, the time period of this pi by 4 3L upon 4G. That is correct also dimensionally. That is correct also dimensionally. But it is not correct in a normal sense. Clear beta? Is this clear now? Pranav, Pradyuman, Kanishka, Bhuvana, Shrita, Mokeshwaran, Samyukta. Meaning of my saying, if you put extra constant or extra algebraic things in front of your you can say units or in front of your this fundamental quantities for fundamental units or fundamental quantities also to create any particular derived formula, so that is doesn't prove dimensional analysis. It here is dimensional analysis. So the dimensional analysis formula or the dimensional formula did not give you or prove the correctness of any equation or formula. You can just prove right hand side, left hand side. Clear? Good. Okay, this is your principle of homogeneity. I gave you already. The principle of homogeneity states that dimension of each of the terms of a dimensions of a dimensional equation on both the sides should be the same. Any other thing you can read it out yourself. An equation of the form x equals to a plus b plus c is dimensionally correct if any only if if and if only if the variables x, a, b, c all have the same dimension. This principle may be applied to differential equations and integral equation as well as to algebraic equation. It should not be assumed that as an empirical equation is necessary dimensionally homogeneous. Okay, this is something you need to understand these words meaning mathematically, then I can teach you physically. Means simple basic thing that particular dimensional analysis can be applied integration on the formula of integration, differentiation, okay, or algebraic equations. Okay, what is the major difference between algebraic equation, exponential equation, or sine function, cos function, or integration? Tell me anyone. Specifically the guys or the students who are in PCM and who are enrolled themselves in JEE. Kanishka thinking what the I'm not going to use this word. I joined physics lecture first time and sir teach me that much. Oh my goodness. And I even not recall any particular previous classes. I don't even go through some classes. So much I need to learn in physics. Hai na beta? You are thinking in this, na? Right now? Yeah, see, that's why I'm saying just, I mean, open your camera so I can read your face. Beta, see, this is you need to do in this weekend at least. It's your duty. That's it. I mean, I can do that last 1 hour class, in last class also in 10 to 15 minutes, but I know that is important. And I'm doing the same thing right now also. Let me see which page I am on right now. 63, maybe somewhere in between. So I'm going to leave you guys here also, because the next coming slide is important and I don't want to do that anything in a hurry. Okay. So, okay, basic difference between these two four algebraic equation is, you can say x equals to a square plus 2bc, in which you have a constant and another variables. This is your algebraic equation. Algebra. Equation. I don't write x equals to ut plus half it square because you get bored of that. I know this. Okay. Then sine cosine function is, then I can write this xt equals to a sine omega t plus phi. I'm writing this specifically deliberately because you're going to see these things in future. So this is your time period, or sorry, displacement of a SHM, simple harmonic equation. So a sine omega t, this is your sine function. Okay, sine, cosine, tan, so many things, but in simple way. AC, alternating current AC, in this way you can find. Sine, or you can say not sine, trigonometric function. Now, metric functions. After that, what I ask? Differentiation. So, but the differentiation is easy. Acceleration, we start from the acceleration. dv by dt. Okay, let's move a little bit higher. Force. Change in, not change. I'm not going to do that change thing. dp by dt. P is momentum here. Clear? Good. Integration. Okay, if you know the dw is the small work done in doing this. Means if you want to go from this particular point to A, and you just know the work done in between this, which is very small length, and this is your dw. So to find the work done from A to B, what you're going to do? Integration. How so? Total work done is integration of A to B dw, which is A to B F dot ds. Why should I do that? Because F is a force applying on this direction, and ds, this is small. Okay. Yeah. Ds is this small displacement. Clear? So this is the last two is, this one is differentiation or differential equation. Not equation but differentiation, simple. TIA EFFERENTIATION. Check the spelling also. Integration. Integration. What remaining? Exponential. Okay. So in the last class I already teach you this. I equals to I naught e to the power anything minus v by t. T is here temperature, not time. Minus 1. This is your exponential equation. Exponential equation. Clear, everyone? Okay. So we stop here. I'm not going to teach you more after this. Principle of homogeneity. And okay, remember in the next class I need to teach from this page. Principle of homogeneity. I don't know which page is this. Okay.